Okay guys, in this video, I will demonstrate the use of your conversion of units for the problems that we would be using in physics. So these are simple mathematical problems that would be used analysis and also your conversion of units. So let's begin. So number one, we'll have a 1 cubic meter cube of an aluminum has a mass of 2.7 times 10 raised to 3 kilograms, and the same volume of iron has a mass of 7.86 times 10 raised to 3 kilograms. Find the radius of a solid aluminum sphere that will balance a solid iron sphere of radius 2 centimeter on an equal arm balance. So I would like to have an answer of the radius of the aluminum sphere to be in centimeter. Okay, so you learned in your solid mensuration that the density of any object is equal to its mass over volume. Or so actually it was learned in your chemistry. Okay, so we all know that it is also equal to your density. In this problem, we already have a given densities of each of your aluminum and your iron. So what are our densities? The density of our aluminum is equal to 2.7 kilogram per meter cube, right? 2.7 kilogram per meter cube. And the density of our iron is equal to 7.86. Don't forget your times 10 raised to 3. Times 10 raised to 3. Okay? So we have 7.86 times 10 raised to 3 kilogram per meter cube. So how did I solve for that? Density, take note of the formula mass over volume. The mass of an iron is equal to 7.86 times 10 raised to 3 kilogram. And it has a volume equal to 1 cubic meter. So next statement is that find the radius of a solid aluminum sphere that will balance a solid iron sphere of radius 2.0 centimeter on equal arm balance. Take note that if we are going to balance any object, their weight should be the same. Therefore, I may conclude that the mass of my aluminum must be equal to the mass of my iron at the volume equal to the radius equal to 2 centimeter. Okay, so let us solve for the mass of your iron. Since the volume or the radius of your iron is given, which is equal to 2 centimeter. So let's say solving for mass of our aluminum. Take note that our row of aluminum of iron. Okay, I should say iron, sorry guys. So this must be iron. Okay. So solving for the mass of iron, we know that the density of iron is given to the problem, which is equal to 7.86 times 10 raised to 3 kilogram per meter cube. Right? So I have my formula, mass over volume for my density. Take note that I can have the volume of my iron. How? We all know that the volume of a sphere is equal to 4/3 pi r cube. Pi r cube, right? So therefore, I may say that this will be my volume of my sphere. Okay? Analyzing this one, I can solve for the mass of my iron, right? by using this formula. Okay, so since you can see that your radius is in centimeter, you cannot solve for centimeter if you have you cannot solve immediately, or you cannot cancel out your centimeter to meter. First, you should know how to convert your centimeter into meter, right? So therefore, my 2 centimeter is convertible into times 1 meter is equal to 100 centimeter, canceling out your centimeter. So we'll have 0.02 meter. Okay? So my volume, therefore, is equal to, this is the volume of my iron. Okay? So 4/3 pi r cube of my iron is equal to 4/3 pi multiplied my 0.02 meter cube. Therefore, I will have a volume equal to, so use your calculator in solving this one. We have a value equal to 3.35 times 10 raised to -5 meter cube. Okay, so we'll have a rho. So substituting the value of your V I, so we'll have Pi, which is equal to 7.86 times 10 raised to 3 kilogram per meter cube is equal to my value of my mass of iron, which is unknown. So Mi is unknown. Okay, Mi is unknown. So I'll have a value equal to my volume, which is equal to 3.35 times 10 raised to -5 meter cube. Right? So by cross multiplication, I will have my mass I. Okay? So take that meter cube is not equal to your mass I. Okay? So we'll have our mass I. Okay? So M is equal to 7.86 times 10 raised to 3 kilogram per meter cube multiplied by 3.35 times 10 raised to 3 meter cube. Canceling out your meter cube, you will have a unit for mass, which is your kilogram. That is SI unit for mass. 7.86 times 10 raised to 3 times 3.35 times 10 raised to -3. So we'll have a value equal to -5, right? Raised to -5. Okay, so we'll have a value equal to 0.266 to 0.26331 kilograms. This is the mass of your iron. So take note. So in order to have a balance mass, your iron should be equal, or should have an equal mass with your aluminum. Okay? So solving for the mass, or solving for the volume of iron of your aluminum, solving for volume of aluminum, will have the density of your aluminum, which is equal to mass over volume, which is equal to 2.7 times 10 raised to 3, 2.7 times 10 raised to 3 kilogram per meter cube, which is also equal to your mass, which is equal to 0.26631 0.26331 kilogram, which is equal to 0.26331 kilogram divided by your unknown volume. So solving for your volume by simply cross multiplication, so we will have a value equal to 2 0.26331 kilogram divided by 2.7 times 10 raised to 3. So we'll have a volume equal to, so canceling out your kilogram, so we'll have a volume equal to 9.7522 times 10 raised to negative 5 meter cube, right? So using this volume, I can get the radius of my solid aluminum. Okay, so let's say this will be your letter C, solving for R of my aluminum. So take note that the volume of sphere is equal to 4/3 pi R cube. My volume now is equal to, let's say this is my volume of aluminum, which is equal to 9.755 times 10 raised to negative 5 is equal to 4/3 pi R cube. Solving for my R, so I will have a value equal to 9.755 times 10 raised to negative 5 divided by 4/3 pi, right? So close and open parenthesis, and then we have our cube, right? So we will raise it into 1/3 in order to eradicate the cube formula. So therefore, I will have chief storat A, so alpha A divided by 4 divided by 3 shift pi raised to 1/3. Okay, we'll have a value equal to 0.028 meters, 0.2855 meters. Take note that the value of your, or the unit for your volume is meter cube, right? So meter cube, so getting the cube root of meter cube is meter. Okay, so this is meter cube. Okay, so this is the answer for your R. So take note that in order to get the value of your radius in centimeter, so we will solve it, or we will convert it into centimeter. So 0.02855 meter times 100 centimeter per meter. So we have cancelling out your meter, we'll have a value equal to 2.85 2.855 centimeter. Okay, that is the solution for your example number 1. So I will create a line in order to separate your ABCDs to avoid confusion. Right? Okay, okay, yeah. That is our solution. Okay, next, your example number 2. Okay, this will be our answer for R. Okay, your example number 2. A solid piece of lead has a mass of 23.94 grams and a volume of 2.10 centimeter cube. So from this data, calculate the density of lead in SI units, kilogram per meter cube. Your example number is very easy, right? There is no need of analysis. It is just pure substitution and conversion. We all know that your rho is just equal to meter mass over volume. So take note that this is a symbol for density. So our mass is equal to our mass is equal to 23.94 grams. Okay? And then our volume is equal to 2.10 centimeter cube. So, we will convert it into a kilogram per cubic meter. So, we have our 23.94 gram. So, multiplied by 1 kilogram is equal to 1000 grams, right? Divided by our volume, which is equal to 2.10 centimeter cube multiplied by 1 meter divided by 100 centimeter. Never forget about the cubic value, right? So we'll have the density for the solid piece of lead in kilograms per cubic meter can be 23.94 times 1 all over 1000 divided by our 2.1 centimeter cube times 1 all over 100 raised to 3. So we'll have a value equal to, so cancelling out your kilogram, cancelling out your gram, okay, and then cancelling out your centimeter cube, we'll have a value equal to 11,400 kilogram per meter cube, right? Next, that is very easy. Okay, next is a rectangular building lot has a width of 75.0 feet and a length of 125 feet. Determine the area of this lot in square meters. So we all know that an area is equal to length times width. So if we will draw the lot, we'll have a length equal to 75, length equal to 125 feet and a width equal to 75 feet. So therefore, there are two methods that you may use. So first method is that you will first convert your feet into meters. So converting your 125 feet into meter, so time is, we all know that 1 meter is equal to 3.28 feet. So therefore, my length is equal to 125 feet times 1 all over 3.28 is equal to 38.11 meters. Or my width is also equal to 75 feet times 1 meter divided by 3.28 feet. So we have 75 times 1 all over 3.28. So we have 22.866 meters. So getting the value of your area is equal to 38.11 meters multiplied by 22.866 meters. So we have times 38.11 times 22.866. So we'll have a value equal to 871.42 meters squared. Next is by simply multiplying it. So second method, you may multiply it directly. So my area is equal to 125 feet multiplied by my width, which is equal to 75 feet, which is equal to 125 times 75. We have 9,300 75 feet squared. Or I will multiply, and then because the problem wants us to have an SI unit in meter square, so we will convert it. So 9375 feet squared multiplied by 1 all over 3.28 feet per meter. So take note that your constant of conversion should be inside the parentheses or bracket if you will square this one. Because if your constant is outside the parentheses, take note that your answer would be very, very, very wrong. There is 1 all over 3.28 squared. So we'll have a value equal to 871.412 meters square. So I will guide you if you will store the datas and then use the stored data and round it off in the second decimal point in your answers in quizzes or SITworks. Okay? So take note that there is a significant difference of your 0.42 and your 0.412 because of the rounding off of your numbers. Okay? That is very easy, right? That is for your conversion of units. So, next. So if a car is traveling at 55 miles per hour, determine speed in kilometers per hour and meters per second. So, in this problem, it is a velocity problem wherein we would just convert it into kilometers per hour and meters per second. So, your 55, so 55 miles per hour into blank kilometers per hour. So, it is very easy, right? So, we all know that we have 55 miles per hour. So, imagining that I do not know my direct conversion of my miles per hour. So, therefore, I will first go to my feet per meter, feet per mile, and then I will convert my feet per mile into feet per meter, and then I will convert your meter into kilometer. So, times 5 to 80 feet per mile, and I have my meter. We have 3.28 feet per meter times I have 1000 meters per kilometer, which is equal to, so canceling like terms because it is just equal to 1. Okay, so I will have a value equal to 55 times 5 to 80 all over 3.28 times 1000. So I will have a value equal to divided by 1000 equal to 88.536 kilometers per hour. So imagining that I know the direct conversion of miles to kilometers, wherein I will just multiply 1.609 kilometers per mile. So 55. So this is my first option. This is my second option. So 55 times 1.609 kilometers per hour, per mile. So take note that my 55 has a unit of miles per hour. So cancelling out your mile, so we'll have a value equal to 88.495 kilometers per hour. Okay? So, take note that your 1.609 kilometers per hour is already the rounded value in your conversion of units. But your 88.495 and 88.536 is almost the same with your 88.8, almost the same with each other. It's just the value of rounding off of numbers has made that significant different. Next, that I will convert this into meters per second. So 55 miles per hour to blank meters per second. So like our previous procedure, so 55 miles per hour multiplied by 5 to 80 feet per mile multiplied by 1 meter has 3.28 feet multiplied by my hour, 1 hour divided by 3,600 seconds. So take note that in conversion of units, it is you who will make your decision, wherein you will make yourself very comfortable in solving the problem. Because once that you will use the method that is not used to you, it would be very hard to cope up, and it might also confuse you in your computation. So we'll have a value equal to, cancelling at your hour, we'll have 55 times 5 to 80 divided by 3.28 times 3,600 seconds. We'll have a value equal to 24.59 meters per second. Okay, that is the value, or that is our answer. So if there will be any question, feel free to ask.